Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, we will see an end-to-end observability project which is developed using a demo application that is developed specifically to learn observability. What does that mean? The demo application that you see here is developed for demoing OpenTelemetry and maintained by top observability companies like Datadog, Dynatrace, Microsoft, Alibaba, Grafana Labs. All of them together work on developing or contribute to the source code of this application so that anybody who wants to learn about OpenTelemetry or observability can use this application for demo purpose. It's an open source project. You can look at the source code here. I will put the GitHub link in the description. And if you go to the SRC folder, you will find all the services and how telemetry is instrumented in these services. I will talk about the code in a while, but before that, you can see the architecture of this application. So the reason why I have chosen this application for the demo today, because this is the best project that is available on GitHub. It's a multi-microservice architectured application, just like any e-commerce real-time application. It has card service, currency service, payment service. For notification, there is an email service. Recommendation of the products, they have a recommendation service, shipping service, and each of it is written in different programming languages. Let's say you want to learn observability using Python. So you can find out the color. So this is the color, which means recommendation service, a microservice, is written in the Python programming language. You can just go to the GitHub repository, search for recommendation service folder. You can see the Python application. And if you go to the code base, let's say you go here, you can see how OpenTelemetry is used for writing the traces and metrics. You can find here, they are using the OpenTelemetry module to import the traces and metrics. And within the code, they are defining the traces and metrics for this Python microservice. So by looking at the code, you can learn, if you are a developer, how to instrument the metrics and traces for Python application. And assume you are a DevOps engineer. If you go to the documentation, you have how to deploy this to Docker. You have how to deploy this application onto Kubernetes with detailed steps. That means using Helm charts, you can learn how to deploy it on a kind cluster, EKS cluster, everything step by step detailed is mentioned in the documentation. So end of the day, what I want to say is if you want to learn observability, this application is the best demo application that you can find on the GitHub, a open source project. Now, Abhishek, should we directly deploy it on a Kubernetes cluster and explore the metrics and traces? Before that, let me explain something very important. If you want to add it to your resume or if you want to learn observability, something that you have to note, which I mentioned in my observability series as well, where I explained observability right from scratch. In order to have a well set up observability, there are two things. First thing is instrumentation of metrics. Second thing is implementation of observability, where instrumentation means your development team who are writing the microservices. In our case, this demo application that is written by multiple observability companies, So these microservices should omit metrics, they should omit logs, and they should omit traces. No matter how simple or complex microservice that you are trying to implement observability. Let's say you are a DevOps engineer or SRE engineer and you want to implement observability. You are given an application, you are given a microservice. The first thing that you should ask is is the microservices instrumented with telemetry data? Telemetry data is nothing but metrics, logs, and traces. So you can also go to the source code, and in the source code you can see. So if you have little development knowledge, for example, as I've shown you, so I went to the Python application and I looked at, okay, what libraries they are using, and in the code at the critical functions, are they omitting the traces or are they scraping the metrics? Are they defining the metrics? I mean, everything you can look at the source code. For example, Go programming language. As a DevOps engineer, you have little understanding of Go, let's say, and you are given a Go microservice. In this application, I have used it multiple times before. So I know checkout service is written in Go. So you can go to this application and click on main.go, and you can see if OpenTelemetry related things are used or not. So I can see in the modules, okay, the OTel, which is shortcut for OpenTelemetry, they are using the trace module, and this trace module is also used in the code so that traces are omitted. Here I can see metrics are defined and exported. Perfect. So this is how observability is a team effort. It's combination of development team who are instrumenting metrics, traces, and logs, and DevOps engineers who are creating the Kubernetes clusters, DevOps engineers who are deploying the applications using Helm charts or operators, DevOps engineers who are setting up Grafana, Prometheus, and whatever is your observability stack, let's say Jaeger and other things. Now, Abhishek, okay, I have the application here, right? And I have the source code also. But one question that I always have is, why should we use OpenTelemetry? And how does OpenTelemetry actually work? So let's understand both of these things. First thing is, why should we use OpenTelemetry? Or why should your development team use OpenTelemetry? This question can be asked during your DevOps interviews as well. The reason for that is there are hundreds of observability tools in the market. Let's say today your company is using Datadog. Tomorrow your company is using Dynatrace. I mean, they want to move from Datadog to Dynatrace, or they want to move from Grafana to Jaeger, or Jaeger to Grafana. Anything, there are hundreds of observability tools in the market. And assume your development team who are writing the microservices today, because the metric stack that you're using is Prometheus. If your development team use Prometheus client, okay, let's say they are using Prometheus client or they are using Nagios client. Tomorrow, when you want to shift from Prometheus to Nagios, or when you want to shift from Datadog to Dynatrace, or one observability company to another observability company, hundreds of microservices that you have in your organization needs this change, because you have hard-coded APIs of Prometheus, you have hard-coded the SDKs of Prometheus, and using which you are defining the metrics. Tomorrow, if your company is moving to another observability stack, the development team has to go to each and every microservice and they need to modify how metrics are defined. They need to modify how logs are defined. They need to modify how traces are defined. Now, this has become a very big problem in the industry, especially in the cloud native space, because moving from observability tool to other has become a very common thing. So what a common thing that CNCF has come with, or a project called OpenTelemetry was developed or introduced, where they said that, okay, we will be a standard where instead of using Prometheus client, use OpenTelemetry APIs and SDKs. And we have something called as exporter, where the developers can use APIs and SDKs of OpenTelemetry instead of things like Prometheus, Nagios, or any specific thing. And in the exporter, you can define if we should expose the metrics to Prometheus, or if we should export the traces to Jaeger. We will do the job. So OpenTelemetry has become a standard so that tomorrow, if you want to move from X to Y, it will not be a problem, because all of these observability companies have agreed to accept the standard that is OpenTelemetry. So now developers started using OpenTelemetry APIs and SDKs. Same is in this demo application. Here you can see, although we are going to perform this demo on Jaeger and Grafana, Prometheus, you will not find the Prometheus client, or you will not find the Jaeger client. But in this demo application, you will find the modules and libraries related to OpenTelemetry. OTel is shortcut for OpenTelemetry. And then you have a file in this project, such as the exporter configuration file, where in that configuration file, you can define what should be your backend, or what should be the receiver of this metrics, logs, and traces. If you are confused, let me explain the architecture so that you will find things much easier. So this is how the configuration flow looks like. What typically happens is, first, so this is the first step where developers, so they develop microservice, let's say. In the microservice, along with their code, the application code, maybe the Golang application code, along with that, what they will do is they will use the OpenTelemetry API and SDKs for omitting metrics, logs, traces, and these metrics, logs, and traces, they are first received by a receiver component of OTel, that is OpenTelemetry. So OpenTelemetry has something called as receiver, which is going to receive this telemetry information. It will process it. So there is another OTel component called as processor, which is going to process all of this telemetry information. And finally, there is an exporter. So final OTel component is the exporter, which can export the metrics, logs, and traces to any backend that you need. So how is this defined? This is defined in the export configuration file of the OpenTelemetry. Sounds good? So this is the standard that is defined by the OpenTelemetry project, and that is why it has become very popular. So tomorrow you can just change this configuration file and update the backend to anything that you want. Let's say your backend for traces is Jaeger. As I have explained in the day 6 of Observability Zero to Hero series, where we learned about distributed tracing using Jaeger. Now, what Jaeger does, if you have watched that video, as the exporter forwards this information, there is again a receiver in the Jaeger or the agent in the Jaeger, which is receiving this information, which forwards the information to the Jaeger database, which is mostly Elasticsearch. And you can attach EBS volumes if you need, right, for backup and storage purposes. And finally, there is a UI component in the Jaeger where user through the user UI component can get this information using the Elasticsearch database. Or let's say the backend is, for the metrics, backend is Prometheus. Again, if you followed my Observability Zero to Hero series, where we learned about Prometheus, what happens in this case? There is a receiver component in Prometheus as well, which receives this information, or it can also scrape the information from the backend. And this information is updated in the time series database of Prometheus. And then there is a Prometheus HTTP server where user can fire PromQL queries and get this information. So this is how OpenTelemetry has become vendor agnostic. Okay, now we talked so much about OpenTelemetry. Let's do this in action, where first we will take a EKS cluster. You can do it on kind cluster, you can do it on Minikube, anything that you want. So let me see if I already have an EKS cluster or not. EKS CTL get clusters. Okay, I already have the EKS cluster. If you are wondering, Abhishek, how can I get one? Don't worry. Go to our Observability Zero to Hero GitHub repository. Link will be in the description. Go to the day 2 folder. Go to the README file. You can find the complete steps for creating the EKS cluster. First, the prerequisites that you need, then run the EKSCTL command, associate the OIDC provider, create the node group. Every step is available. So you can just follow these steps, literally copy paste the commands, and you can get a EKS cluster. Okay, I have the EKS cluster with me. Now, what are the next steps? How to deploy this complex multi-microservice architectured application onto a Kubernetes cluster, right? How do we get this onto a Kubernetes cluster? So for that, just click on the Kubernetes. So this is the documentation link for the demo application. If you go to the GitHub project and if you scroll down, you will find the Docker and Kubernetes related documentation. Directly click on Kubernetes, you will go to that page. And make sure you focus sometime on the architecture. As I told you, it is very, very important project for your resume. If you want to talk about observability in your interviews, this project is going to help you a lot. Multi-microservices written in different programming languages, whichever programming language you are comfortable with, identify the color, go to that particular microservice, Python recommendation service, Go. Go is basically the product catalog service. Go to that GitHub repository, see how telemetry is instrumented, and finally come back to this official demo application documentation and click on Kubernetes. Two simple steps. First one is you need to add the Helm chart. Let me click on it. Okay, it says Helm chart is already available. Second simple step is just fire this command helm install my hotel demo followed by the helm chart, right? OpenTelemetry demo. I already have this demo application up and running because initially I wanted to show you at the beginning of the video how the UI looks and what exactly this application does. So if I just do, I've taken another tab, and if I just do kubectl get pods, you can see all of these microservices. So I think maybe 15, 16 pods, more than that, I think 20 pods, all of them related to this simple project. I mean, this single project. It's a complicated project so that you can learn end to end, not only observability, you can use it for learning DevOps and cloud as well. Use it as your demo project. Perfect. So once the application is installed, now how do you expose this application? Because different people are using different Kubernetes clusters, what I would recommend is just for your learning purpose, use port forwarding. So this is the command available in the documentation. kubectl port forward the front end proxy on the port 8080. Once the port forwarding is done, copy this 127.8080, paste it on your browser. One important thing to note, if you are not doing this on your laptop, and let's say you are doing it on an EC2 instance or Azure VM, what you need to do to this port forwarding command, you need to just add hyphen hyphen address 0.0.0.0, and instead of accessing it on 127.0.0.1, access it on your EC2 instance public IP address. That's it. That's the only change if you are using a cloud instance. Okay, so now I executed the port forwarding command and I went to the application. Because you want to learn about observability, try to add few applications to the cart, try to perform some actions so that once you have Jaeger, once you have Grafana, you can see the traces. Only if you execute few things, you can see the traces, right? Of course, this demo application also has a fake load generator. So even if you don't perform actions, you can see the load. But if you want to see your own request traces, if you want to see your own request metrics, better you add few things to the cart, change the currencies, click on multiple microservices of this demo application. Okay, now how do I access, let's say I want to learn the traces. How do I access the Jaeger user interface? Again, you don't have to do much for this demo application because this demo application already comes with Jaeger installed. As you have executed this Helm chart, right? If you do kubectl get pods, you can see that Jaeger is already installed using this Helm chart. So again, you don't have to go to Jaeger official files, or don't have to go to my GitHub repository and find the steps how to install and configure Jaeger. Of course, if you want to do it with Datadog, if you want to use the same application with Datadog, then you need to go to the Datadog documentation, learn how to install Datadog using Helm chart. Because for standardization, this project is coming up with Jaeger. If you want to change something else, this project definitely supports, but they cannot create 50, 100 observability pods. So they have used Jaeger, they have used Prometheus, and they have used Grafana. Okay, so what does the project say? Just provide this URL. So just append, or let me take a new tab and okay, my bad. just do UI and you can see the Jaeger user interface. And you can see all 17 services. As I told you, there is a fake load generator in the project, which is generating the fake load so that you can understand different traces. So just select one of these services. Let's say I want to select the catalog service, or let's select the cat service. So click on find traces. You can find the complete traces of this application, which all microservices called the card service. For example, the front end application called the card service, and that request propagated. You can see the context propagation. So the context propagation happened from the front end web to the front end proxy, explained as explained in the architecture. First, there is a front end proxy. From there, front end. From there, we were looking at the card service, right? So this is the card service. So from there, the request has to go to the checkout service. From checkout, a gRPC request has to be made to the card service. Let's see that in the traces, if it is correct or not. See, from there, it went to the, from front end, it went to the card service, and within the card service also, you can see to which service exactly it went, or the which function it went. It went to the get cart function. You can click on each span and you can see how much time each span took in the microseconds. You can see the container ID, the cloud region, where exactly it is installed on a EC2 instance of Kubernetes cluster. Everything you can get using this span information. If you want more details, just click on this arrow and you can get the complete details in the well formatted structure. Basically, everything that Jaeger provides. So similarly, you can also go to any other microservice. So we looked at the card service, right? So you can go back and you can look at any other service like checkout service and click on find traces. So there are 47 spans to reach out to the checkout service, because to check out a service, first you need to add an item to the cart. Only if you add an item to the cart, you can go to checkout. So that's why the span clearly explains that from front end, it goes to the cart service. From there, it goes to the checkout service. And if anything goes wrong as well, you can see in the traces very clearly. Now, Abhishek, okay, everything is clear with traces. Can I also see the metrics? Definitely. In the demo application, again, if you click on Kubernetes and scroll down, it also comes up with the Grafana user interface. Grafana is also installed using the same Helm chart. If you click on it, there is no username password that is required. Authentication is disabled. And in the Grafana dashboard, you can see there is a predefined dashboard, and you can also define a custom dashboard. So if you go to the dashboard section, there is already the demo dashboard that is available, where in the demo dashboard, you can see the latency that is occurred for the front end, the error rate for the front end. No, Abhishek, I don't want to use the default dashboards. Click on new, create a dashboard, add visualization. Of course, your backend has to be Prometheus, and you can fire your PromQL queries as well. One thing to note is this Prometheus instance or this Prometheus data source does not scrape metrics information related to the nodes as well as related to your Kubernetes cluster. For example, let me do pod. So you can see there is no information related to the pod. Even the suggestions does not show me anything. Or let's say I want to get any node CPU related information. There is nothing about it. Why? Again, as I've explained in the previous classes, for Prometheus to scrape metrics from the nodes or to scrape metrics from the database or to scrape metrics from the Kubernetes clusters, what Prometheus needs is exporters. If you look at the pods that are installed, you will not see kubestate metrics pod. You will not see the node exporter pod. So that's why Prometheus cannot get any information about the underlying nodes or the Kubernetes cluster. If you want to do that, you need to install the node exporter. You need to install the kubestate metrics. For that, just go to day 3 folder and you can see how kubestate metrics can be installed. Sorry, day 4 folder, and you can install Prometheus with the complete Prometheus stack so that kubestate metrics and node exporter are installed. Or you can do it on your own as well. So you can fire a PromQL query. Let's say I want to get the HTTP server duration seconds bucket. So fire a query and you can see different services here. There is a flag service. And if you reduce the time span, let me do it for 5 minutes. So you can see the HTTP status code. You can see the HTTP server duration of this flag service for the last 5 minutes. Similarly, change the different queries that you want. If you want anything related to the app recommendation, so there is a recommendation service, right? And within the recommendation service, in this GitHub repository, there is a counter that is defined for the number of recommendations it is showing. If you run this query and change for, let's say 1 hour or change for 5 minutes, you can see if it has suggested any recommendations for us. Of course, this application did not show any recommendations for us, right? Right now it is showing, but before, when we added the application to the cart, it did not show any recommendations for us. That's why the query is returning 0 values. Perfect. So this is how you can play with Grafana. You can play with Jaeger. That means metrics and traces using this OpenTelemetry demo application. It is worth spending time on the architecture, spending time on the code base, even though you don't understand the application code. Even if you're not a developer, just spend some time within the programming language of your choice and see what exactly they are doing for instrumenting the metrics. For the Kubernetes part and Docker part, things are pretty clear in the documentation. Links will be provided. You can play around with observability. If you have any questions related to this project, or if you want me to cover anything specific for this project, let me know in the comment section. I will definitely take out time and do it. See you all in the next video. Take care. Bye-bye.